So what we're going to be doing today is looking at some fundamental identities or formulas or theorems that'll be applying to our trig functions and related to the unit circle. So we'll be looking at section 1.5 today. So we've actually already discussed periodic properties in terms of our trig function, but just to kind of clarify and talk about periodic properties, what it means to be periodic is that properties repeat themselves after a certain cycle. For example, think about months in a year. Every 12 months, the months in a year become repetitive, they repeat. So we would say that the periodic property of the months of the year is 12, because after every 12 months, it becomes repetitive. There are periodic properties from our unit circle related to our 6 trig functions. So for example, sine, it becomes repetitive after 2 pi or after 360 degrees. So we could say that the sine of whatever angle we're looking at will be the same as plus 360 degrees times n. And again, n represents any integer. So it could be -1, 0, 1, and so on. Or in radians, we would say that it would be equal to the sine of theta plus 2 pi n. So all that means is when you're given an angle in the unit circle, for example, if you're looking at 45 degrees, well, if I take 45 degrees and add 360 degrees to it, the sine of 45 degrees is going to be equivalent to the sine of 405 degrees. And that periodic property also is for cosine as well. So we would say that the cosine of theta is going to be equal to the cosine of theta plus 360 degrees times n, or in radians, it's going to be the cosine of theta plus 2 pi n. Its reciprocal functions have the same period as sine and cosine. So again, for cosecant, it's going to be, again, the same as the sine, the cosecant of theta plus 360 degrees times n, or in radians, the cosecant of theta plus 2 pi n. And again, the same thing with the secant. It's going to have the same properties as its reciprocal cosine. So again, that's going to be your secant of theta plus 360 degrees times n, which is equal to the secant of theta plus 2 pi n. Tangent and cotangent are the two that are different. Tangent and cotangent do have different periodic properties. And again, we'll look at those more in a little bit, but tangent, it doesn't have that periodic property of 2 pi. It's simply going to be pi. So the tangent of theta plus 180 degrees times n, or in radians, it's the tangent of theta plus pi n. And same with its reciprocal cotangent. So again, the tangent, cotangent of theta plus 180 degrees times n, or in radians, the cotangent of theta plus pi n. And we'll look at examples number 1 together after the quiz. So another thing that's common that helps us when we're looking at our unit circle is the signs of the trig functions. In other words, we know that sine, remember, is our y coordinate, cosine is the x coordinate, tangent is our y divided by x. So in quadrant 1, because remember in quadrant 1, both your x coordinate and y coordinate are positive, all of your trig functions are positive in quadrant 1. Sine, cosine, secant, cosecant, and cotangent. They're all positive in quadrant 1. In quadrant 2, your x coordinates are negative, but your y coordinates are positive. So what happens then in quadrant 2, so again, my x is negative, my y is positive. So remember, because your x coordinate is cosine, cosine is going to be negative in quadrant 2. Along with, again, remember, tangent is y divided by x. So a positive number divided by a negative number is also going to produce a negative tangent in quadrant 2. The only trig functions that are positive in quadrant 2 are going to be the sine and the cosecant. So I'm going to put an S here to help us remember that sine is the only one that's positive. Again, this is telling us what's positive. And I'm going to put a quick little saying here. I'm going to call this students. So in quadrant 3, remember, the x and y are both negative. So since sine is your y coordinate, sine has to be negative in quadrant 3, along with the cosine. But remember, since tangent is y divided by x, a negative divided by a negative is a positive. So the only trig function that's going to be positive down there in quadrant 3 is your tangent. And I'm going to abbreviate this as take. It's a quick little saying, a silly little saying to help us remember what's positive in what quadrants. Then finally in quadrant 4, when you have a point in quadrant 4, remember your x values are positive, your y values are negative for any point in quadrant 4. So since cosine is your x coordinate, I know cosine is going to be positive in quadrant 4. So since sine is your y coordinate, that has to be negative. And again, tangent y divided by x, and negative divided by positive is a negative. So only cosine is positive in quadrant 4. And I'm just going to put calculus. So my quick little saying, all students take calculus. Hopefully that reminds you to double check to make sure you have your negative signs for the correct quadrants. So your signs of your trig functions help us hopefully make sure that we know which trig functions are. Remember, everything's positive in 1. Only sine and cosecant are positive in quadrant 2. Tangent and cotangent are positive in quadrant 3. Cosine and secant are positive in quadrant 4. And like I said, we'll come back and do those examples together. Fundamental identities. So again, when we say any power will apply, again, when we talk about squaring a trig function, so for example, a sine of theta squared means we're taking the sine of theta and multiplying it by sine of theta. Now a trig notation, another way you may see this written without the parentheses is that sine squared theta. This is not equal to the sine of theta squared. This just means you're squaring that angle. So remember, we need to remember that this notation and this notation are equivalent. So when we talk about the sine of theta, your reciprocal identities, we know the reciprocal of sine is cosecant. So I can say the sine of theta is 1 over cosecant theta. And vice versa, cosecant would be equal to 1 over sine theta. Cosine theta will be equal to 1 over secant theta. Secant would be equal to 1 over its reciprocal, which is the cosine of theta. Tangent is 1 over cotangent theta. Cotangent theta would be 1 over tangent theta. Now, when they say any power applies with these particular theorems, what this means is that I could take the sine squared theta and it would be equal to 1 over cosecant squared theta. So it will apply if you're dealing with sine or your other trig functions raised to higher powers. Quotient identities, we use this quite a bit. Tangent of theta. So remember from the unit circle and what we've been studying, remember tangent theta is equal to y over x. Remember y is our sine trig function. X is our cosine. So when I talk about the quotient identity, that just simply means that tangent of theta is equal to sine theta over cosine theta. And again, any power is going to apply. So I could write this is sine squared theta divided by cosine squared theta, and it would also apply. Cotangent, remember, is the reciprocal of the tangent. So cotangent of theta is going to be the reciprocal of sine over cosine. So cotangent of theta, I can write as the cosine theta over sine theta. X over y, remember cotangent's x over y. So cosine over sine. It also applies for other squares, the cosine squared theta over sine squared theta. So those are some fundamental theorems that we'll be talking about in this section.